321 means it's actually recording. Okay, so we're going to look at 1 and 2. Huh? I don't have any. 1 and 2 for the first ones, and then as we go through the rest of the week, I will answer questions on more. So on 1 and 2, when we're looking at it, just looking at it, can you see what function it is? Do you see what parent function it is? Do you see this thing right here? Oh, go away. I didn't talk to you either. Do you see that that's squared? Does that mean that's the function we're looking at? Yes. Okay, that's the function. That's squared right there. So what's not on here is I want you to name them because, like I said, I found out on my homework it's important for y'all to know that. I know them, but y'all don't. So that's a quadratic. We haven't got to it yet. You probably saw it in Algebra 1. We're going to get to conic sections. This is also a parabola would be acceptable answer. Oops. I can't spell, but that's why I'm a math teacher. Squared is not appropriate because it is squared. That's too simple. Okay? So the names we're looking for are quadratic and parabola. Why? Because I might say the parabola or the quadratic parents function. I need you to know what that means. Got it? All right, looking at this, I can tell you what happens. Some of you already can, some of you can't. This right here, what's happening because of the +1 inside there with the x? It's left 1, thank you. I was really pleased y'all got that part. They got the left. Okay, what does this tell me? Down 2. And then what does this tell me? It's reflected, right? So that one's reflected across what? Not the y. Across the x-axis. And then the last thing you see is this half. What does that do? It's vertical. What kind of? It's not horizontal. It's vertical because it's outside. What is it? Vertical compression. It means it's going to go up half as fast. Okay, so to do domain range increasing, decreasing, do we need to graph it first? I can graph this thing really fast without making a table. But if you're not there yet, should you make an XY table off to the side, like way over here?
Yes.
X, Y. And you're going to at least, at a minimum, put my favorite numbers in there, which is -2, -1, 0, 1, and 2. All right, so I'm going to put in -2. I'm going to put -2 in here. What's -2 plus 1?
1.
-1. Right? What's -1 squared? 1. What's 1 times -1/2? -1/2. What's -1/2 and -2? -2.5. Yes, you can. Do you have one?
No.
Well, okay, there's a problem here. I don't have enough functioning ones. So what did I say you should do? If you want to make sure you have one the day of the quiz, the test, or whatever. I went by Walmart. They don't have the dollar ones anymore, but they got $5 ones. Is it worth $5?
No.
And are you going to go to college? Are you?
Yeah.
In math classes in college, will they often let you use a 4-function calculator as long as you're not going STEM? Yeah. And so making a $5 investment now is worth it. All right. I sold that. Sort of. Not really. But that's as much of a plug as I'm going to put in there. Okay, put in -1. What's -1 plus 1? 0. Would it be helpful if I wrote out this math for you? Because I can. All right, so I need another piece of paper. So we're going to go in here, and I'm going to add a page so I can do the math for you. So I think it's here. Page manipulation. I'm going to add one after check. Okay. So it should go away. Down here. Here it is. So for number 1, this is our work for number 1. So for number 1, the equation was what? It was y or f of x equals, which is same as f of x, is equal to -1/2 x plus 1 squared minus 2, wasn't it? Did I remember it correctly? So here's our xy. xy. For negative 2, what I did was I did negative 1/2 times negative 2 plus 1 squared minus 2. What did that give me? That gave me negative 1/2 times negative 1 squared minus 2. Negative 1 squared is 1. 1 times a half is negative a half. That makes this negative 2.5, right? Yeah. Put in negative 1. I get negative 1/2 times negative 1 plus 1. OMG, what's that go to? 0. So this ends up being negative 2, because 0 times negative 1/2 is still 0, and 0 minus 2 is negative 2. Put in 0. I have negative 1/2 times 1 squared minus 2. Is that going to be a negative 2.5 again? It is. Anytime the squares end up being the positive and negative of a number, they're going to square and it's going to come out the same thing. So put in 1. So I put in 1. Do I have negative 1/2 times 1 plus 1 squared minus 2? What's 1 plus 1? 2. What's 2 squared? 4. So now I have negative 1/2 of 4 minus 2. That would be a negative 2, and a negative 2 is negative 4. Right? Huh? 2. Negative 1/2. 2 plus 1 squared minus 2. That becomes 3 squared. What's 3 squared?
3 squared is 9.
Yep.
Oh, for real?
For real. What's half of 9? 4.5. So negative 4.5 minus 2, and that one's negative 6.5. Can you graph all those points?
No.
Okay. Oh, it's a half step. You can do a half step. I'm pretty sure you can do a half step. How about between? Do you understand between? Okay, you can do between. Just put it between the dashes. Get it close, I'll count it. I'm going blind from grading your stuff anyway. It shouldn't be a problem. I'll look and go, it's close enough. All right, so my points, at negative 2, it's negative 2.5. At negative 1, it's negative 2. At 0, it's negative 2.5. At 1, it's negative 4. And at 2, it's negative 6.5. Does that make sense? Yeah, because what did we do? We shifted it 1 left. So does that mean the vertex is at negative, is on that line, x equal to negative 1? Do you remember anything from algebra 2? That's what you learned. Okay, really fast, we're going to graph this now, because we have these points now. What did I get at negative 1? Tell me. Negative 2. What did I get at 0? Negative 2.5. What did I get at 1? Huh? Say it louder. Negative 4.5. And what did I get at 2? Negative 6.5, right? Is that right? Let's look. Oh, negative 4. It was negative 4, you're right. Not negative 4.5. It was negative 6.5 is the next number. I didn't remember it. There we go. That's better. So we're going to graph those now. We're going to make our little tick marks. 1. Oh, I want to make them bigger than that. 1, 2. I'm going to exaggerate the width. But then I have to get up to, I have to go down. I have to go down to 6. So I have to go 1, 2, 3, 4, 5, 6. Right? So at negative 2, it's negative 2.5. 1, 2.5, it's about there. At negative 1, it's negative 2. At negative 1, it's negative 2. At 0, it's negative 2.5. At 1, it's negative 4. 1, 2, 3, 4. And at 2, it's negative 6.5. Is the rest a parabola? This is the vertex. Is this one going to be a mirror image over here? And this one's going to be a mirror image over here. And can you just draw this in now? It goes like this. And it goes like this. Is that what it's going to look like? Now, your quiz was much easier than that. I didn't make you do the reflection. I didn't make you do compression. All I made you do was shift. You shifted up or down and you shifted left or right. Shift is definitely going to happen every time. Yes? Okay, what about 2? What function is this one? Name it.
Square root.
Square root.
Oh,
Yeah. Transformations. What does this plus 3 do? Up 3. What does the 2 do?
To the right.
No. It's times the whole thing. So you're stretching, right? It's vertical stretch. Is anything on the outside, not with the X, going to be vertical? So this is vertical up or down, this is vertical stretch, and if it's reflection, it would be vertical reflection. If it's inside with the X, what is it? It's horizontal. So what does that negative do? Horizontal, so what? It's a reflection? What is it a reflection across if it's horizontal? No. Don't say X just to say X. It's reflection across the Y-axis. Because is this horizontal? This is vertical. Oh, by the way, I'm leaving y'all the domain range intervals of increasing and decreasing. Can you look at your graph? Once you have the graph, can you answer those questions? We'll see. That'll be on your quiz tomorrow. No, that'll be on your quiz Tuesday, sorry. Tomorrow's is just symmetry. Even, odds, x-intercepts, y-intercepts. Huh? Oh, there was a quiz today. Oh, well, it'll be tomorrow because there's no time for that.
I tell you, man, you can't tell me what God won't do.
Huh? Oh, y'all just stop. Oh, whatever. Today we're supposed to be symmetry, but we don't have time for that because of this other quiz and me going over. I'm not even doing piecewise today. I'm still doing transformations that y'all didn't bother doing your homework for. Okay. So, will this one be easy to graph? X, Y. Right? So I need those points. I'm going to come all the way down here. So for number 2, my equation was y equals 2 negative square root plus 3 or minus 3. I can't remember. Plus 3, right? I have x. I have y. I'm putting in my favorite number, negative 2. So that means it's 2 square root of negative 2 plus 3. Sorry. Right? Well, a negative of a negative. So is this going to be ugly number? Okay, right there, it's going to be 2 square root of 2 plus 3. Do any of y'all know how to graph that? Nope. Okay, so that's not a good number. All right. Do I need a perfect square in there? So I need negative 4. Do you understand why? Watch this. It's going to be 2 square root of negative 4 plus 3. Does that become 2 square root of 4 plus 3? What's the square root of 4? 2. 2 times 2 is 4 plus 3 is 7. It's 7. Okay, next perfect square is negative 1. 2 square root of negative 1 plus 3 is just going to be 5 because it's 2 times 1 plus 3. 0 works. 2 square root of 0 plus 3 is going to give me what? 3. Can I put in 1 and keep it real? Can I? If I put in 1, do I get a square root of negative 1? Is square root of negative 1 imaginary? Yeah, because we're just going to do positive, so do I get to stop there? I could put in a negative 9 if I wanted to. Negative 9 works. Negative 9, 2 square root of negative 9 plus 3 is going to be 2 square root of 9 plus 3, which is 2 times 3, which is 6, plus 3 is 9. So negative 9 works. Yours is a lot easier than this. This is harder than what I gave you on your quiz. Shall we keep going? So I have the points, and I like them. Negative 9, negative 4, negative 1, and 0. And negative 9 was 9. What was negative 4? Negative 4 was 7. 7, 5, and 0 was 3, wasn't it? Did I get that right? Negative 9, so I got 9, 7, 5, 3. So let's graph this puppy. So, going all the way here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and I wasn't perfect on my spaces, but it's good enough. Negative 9, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down here. Boom. Negative 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. About right there. Negative 1. I got them drawn in the wrong place. I'm supposed to be going up. Y'all let me do that. Okay, I got to move this. Can I do that? I don't know how to do that. I'm just going to erase it because I need that room. I was supposed to be going up, and y'all let me go down. Y'all let me down. 1, 2, 3, 4, 5, 6, 7, 8, 9. All the way out here. Right? And then it was negative 7. 2, negative 1, 2, 3, 4, about there. And then it was am I doing that right? I got that right, right? What am I doing wrong? I'm going the wrong way. I'm doing the wrong ones. I've got negative 9 should be 9. And then negative 4, 1, 2, 3, 4 should be 7. That's better. Right there. And then negative 1 should be 5. 1, 2, 3, 4, 5. There we go. And then 0 should be 3. Does that look like a square root that's been reflected across the x-axis and stretched and shifted up? Now do you see it? Because what does square root look like? Just for information, does square root look like this one? The parent function, does it look like this? So I have taken this, I have flipped it, I have shifted it, and I have stretched it. Right? Everybody got it? Okay, that's enough for today on that. Because we got to go on to piecewise. No, you know what? I'm just going to we're just going to shift the calendar. All right? We'll do the other piecewise tomorrow. We'll do the other quiz tomorrow. So you should look at your symmetry tonight. Yes, you should. Okay, so let me find, do I even have this thing? There it is.